Hello students, a warm welcome to all of you at AriserTalent. How are you all? I hope all of you are doing amazing. So, we have started in our last section the fourth chapter of the class 9 chemistry, that is about the structure of atom. Clear? So, what we have discussed until now, in our first lecture, we have seen the introductory part and we have seen that we have the three fundamental particles of the atom, that is about the electron, proton and neutron. So, today we are going to cover the topic that how the discovery of these fundamental particles will happen. Clear? So, firstly, we are starting with the discovery of electron. So, the first topic is all about discovery of electron. In our first lecture, we have seen that electrons are negatively charged particles and having a charge of minus 1.6 into 10 raised to the power minus 19 coulomb on that. Clear? And the molar mass for this will be 5.48 into 10 raised to the power minus 4 gram per mole. That is the molar mass for the electron. So, actually the credit for the discovery of the electron goes to Sir J.J. Thomson, but before that many scientists came and gave their different perceptions about the discovery of the electron. So, in the sequence, firstly, Julius Pricker have said that the electrons are the particles, or we can say that they are the corpuscles of negative energy. But then G.J. Stoney termed these particles as the electron, and Sir J.J. Thomson has performed his experiment on the electric discharge tube that is designed earlier. So, this electric discharge tube gave the experimental proof for the discovery of the electron. So, firstly, we can see that electrons are particles of negative charge. So, I can say that negatively charged particles are electrons. Negatively charged particles are electrons. And what is the charge on them? The charge on them is minus 1.6 into 10 raised to the power minus 19 coulomb. Clear? And if I am talking about the molar mass of electron will be 5.48 into 10 raised to the power minus 4 gram per mole. This is the molar mass for the electron. So, firstly, Julius Pricker have said that electrons are the particles of negative energy, and J.J. Thomson termed it as a negative corpuscles, and then G.J. Stoney termed the electron first time. So, after that the electrons are named as electrons, they are not named as the negative corpuscles of energy. Clear? So, J.J. Thomson performed his experimental proof on the electrical discharge tube by performing the experiment at a very low pressure and a very high voltage. The high voltage is kept about 10,000 volt to observe the movement of the electrons. So, the whole credit for the discovery of electron goes to Sir J.J. Thomson. So, J.J. Thomson performed whole experimental proofs regarding the electrons. So, what he has done, he has taken a electric discharge tube which consists of cathode, anode, electromagnets and source of battery and a fluorescent screen. So, firstly, let's see the diagram that what he has taken to perform his experiment. So, firstly, he has taken a electric discharge tube. In this electric discharge tube, he has taken a cathode. So, the first thing taken by him is cathode. He has taken the cathode here. Now, after this, between the fine hole at the center, the anodes are taken. This is a part which is anode. Clear? So the anodes are taken at this part. So this part is our anode. After this anode, a fine hole is made in the center and the two metallic discs are taken here. These are the two metallic discs taken by him. So this is M1 and this is M2. And this is what? This is our cathode. So I can say this is cathode, this is anode, this is two metallic disc. Now, two electromagnets are taken here, and what is the purpose of these electromagnets? So if you want to apply the electric and magnetic field, we can vary it by using the electromagnets here. So this is the two metallic plates, that is M1 and M2. After that, he has taken a two strong electromagnets. So this is electromagnets. Now the two plates are taken, P1 and P2, through which the electron beam is going to be passed. This is plate P1 and this is plate P2, and this is our fluorescent screen. This is the screen on which the whole phenomena is observed. This system is connected to a source of high voltage battery. This is the source of high voltage. So, this is the electric discharge tube through which the discovery of the electron has been done. So, what he has taken, in the first part, he has taken a cathode. After cathode, he has taken the anode. Anode and two metallic plates M1 and M2 are made to be taken at the fine hole. Now electromagnets are taken to change the source of vary the electric and magnetic field. Two plates P1 and P2 are taken so the ray can easily pass through between them, and a fluorescent screen is taken so you can observe the deflection occurring in this experiment. So what happened when there is no electric field applied to the system? In the absence of the electric field, you can see that the ray is going to pass straight and you will observe it on the point number P1 in the absence of electric field. As soon as electric field is applied to this system, what will happen? The particles will pass and they are going to deflect in this direction. So now you will observe a bright spot on a point P2. So what you have seen that the particles that are passing through this electric discharge tube are bending towards the positive charge. If they are bending towards the positive charge, it has been proved that the particles are negative particles and these particles are termed as electrons, and the rays which are passing through it are known as the cathode rays. Clear? So this is a very simple experiment that is done in the electric discharge tube. So simply in the absence of electric field, you will observe a bright spot at point P1, but as soon as the electric field is applied, you can see that the point is shifted to P2 and a bright spot is seen as a P2, because in the presence of the electric field, the particles will show some deviation. If they are moving towards the positive charge, it is concluded that the particles are of the negative corpuscles of energy and these particles are simply termed as a electron. Clear? Now, what are the property of the cathode rays are concluded from this experiment? Firstly, the particles or the cathode rays are traveling in a straight line. Particles are traveling in a straight line. So, let's see what are the properties here. Next thing is properties of cathode rays. So the first thing that was observed is cathode rays travel in straight line. In absence of electric field. Second thing was observed that these rays have a tendency to pass through aluminium foil because they are crossing the screen, so it have a tendency to pass through the aluminium foil. They can pass through aluminium foil. Clear? Cathode rays have a tendency to affect the photographic plates because they are affecting the fluorescent screen, so they are simultaneously going to affect the photographic plates. So, these rays have a tendency to affect photographic plates. The next point about the cathode rays that is concluded from this experiment is that E by M ratio will be same for all the particles. E by M ratio means charge to mass ratio. If I am saying that E by M, E is the charge on the electron and M is the mass of the electron. So, E by M ratio will be same for all the particles in the cathode rays. So, E by M ratio is same. And the last point that is concluded about the cathode rays is that they are going to produce the ionization of the gases. Clear? So, they produce ionization of gases. So, this is a very simple activity, or you can say simple experiment done by Sir J.J. Thomson in this electric discharge tube. This is electric discharge tube used by J.J. Thomson for performing his experiment, and this is experimental setups and the devices or the things he has taken to conclude his experiment, and these are some of the properties that he has found after the discovery of cathode rays. So, just copy this part from here so we can proceed to the discovery of proton. Now, the next topic is about discovery of proton. Electrons are the particles that are negatively charged. So, on the other hand, protons are the particles which are positively charged. So, we can say that positively charged particles are protons. And what is the charge on them? The charge on them is now plus 1.6 into 10 raised to the power minus 19, and the mass of the proton is 1.627 into 10 raised to the power minus 27 kg. Clear? So, this is the main features of the proton. Now, the credit for the discovery of the proton goes to Goldstein. Goldstein used the same conduction tube and performed the simple experiment, and he has discovered the proton, or we can say he has discovered the anode rays, that is known as the canal rays. Clear? So, firstly, protons are the positively charged particles. Protons are our positively charged particles. Charge on proton is plus 1.6 into 10 raised to the power minus 19 coulomb. This is the charge on proton. The mass on proton is 1.62 into 10 raised to the power minus 27 kg. So, this is the mass of the proton. Now, the whole discovery is done by a scientist name that is Goldstein. He has performed the complete analysis on the discovery of proton or the discovery of anode rays, or we can say that the discovery of the canal rays. Clear? So, Goldstein performed his experiment and he has discovered a new type of the rays that is known as anode rays or canal rays. So, this is the another name for the protons that is leads to its discovery. Now, he has taken the same electric discharge tube that was discovered earlier. So, in the same discharge tube, what he has done, let's see here. So, the same discharge tube has been taken by the Goldstein and he has discovered a new kind of the rays that is known as the anode rays. So, for this experiment, what modifications he has done? He has taken here a perforated cathode. This is perforated cathode. So, this is perforated cathode. Now, what is perforated cathode? Perforated cathode is actually a cathode which is having a fine holes in between them. Okay, so discovery of the canal rays is done by using this perforated cathode and he has done some modifications in this glass tube for performing this experiment. So, in the presence of the perforated cathode, he has observed that there is some rays which are going to move in the opposite direction. He has seen that apart from moving in this direction, there are some special rays which are deviating in this direction and he has termed this type of the rays as anode rays and canal rays, and after that the discovery of the proton has been done. Now, after this discovery of the proton by using the perforated cathode, he has also found some characteristics of the canal rays. So, what are these properties of a canal rays? Let's see here, but before that you can copy it from here. Now, let's move to the property of anode rays. first property of the anode ray is that these rays travel in straight line. These rays travel in straight line. Second thing is that the E by M ratio will not be same here. You have found that in case of the cathode rays, we have seen that the charge to mass ratio will be same for all the gases. But in case of the anode rays, you will not get the E by M ratio same for all kind of the particles. So I can say that E by M ratio will be different. E by M ratio will be different. These rays is able to produce fluorescence as they are affecting the fluorescent photographic plate also, because they have a tendency to produce the fluorescence on the screen. They produce fluorescence, they are going to affect photographic plates. They are going to affect the photographic plates, and they have the tendency to produce ionization of the gases. If you want to ionize any gas, you can simply use the cathode or anode rays both. So, they have a tendency to produce ionization. So, these gases will have a tendency to produce ionization. So, one thing you have to keep in your mind that for performing this experiment, so in this glass tube, we have taken a perforated cathode, and you can simply mark, you can see that you can simply mark cathode here, and we have observed that some rays are moving in the opposite direction. So, these are our anode rays, that is the canal rays. So, until now, from the first lecture, we have discussed about the Dalton's atomic theory. We have seen the three kind of the particles, that is electron, proton and neutron, and in our today's lecture we have a discussion about electron and proton. So this lecture is over here. We will continue with the discovery of neutron and other atomic models in our next lecture. Thank you so much and have a nice day.